Hello and welcome to another video. And today we have a B450 Aorus Pro on our bench. Had this mainboard quite often before. This also came in a job lot. Don't know what is wrong with it. Already can see that something weird has happened with the heatsink for the PCH. Don't know what, something is missing and something seems like it was glued on there. But let's just see for the passive power consumption how this board behaves, and let's go from there. So we will need a processor because that always changes the passive power consumption. So let's put one in, and let's plug the passive power consumption in, the 24 pin, and activate our power source. And we have almost 1 amp. There was at 12 volts we just had. It's kind of hard to see on this one, but let me tell you, it's 12 volts at 1 amp. So something is definitely shorted on one of our rails. So something that takes passive power consumption from the 5 VSB is shorted. This might either be one of the regulators for 3.3 volts or maybe the SIO itself. Yeah, one of these most of the time. For that, I would want to remove these heat sinks in order to get a good view of what there is on this board. So let me quickly take off all of these heat sinks. So I've now removed the heat sinks, as you can see, for the SSDs and for the PCH. And let's see for the resistance. Let's check with the 5 VSB first. And the 5 VSB seems to have high resistance. Let's check without this thing attached. Let's see. Let's get a good ground. But yeah, it's high resistance. Let's check other things that are on the standby line. So what I can always check is on these capacitors around the SIO. So one side is ground. So you can see low resistance. Like that. And then trying the other side, it's high resistance. Let's check some difference one, low resistance and high resistance. Okay, so around the SIO also seems fine. There's a standby regulator down here, this thing, and its output seems to be high resistance as well. There's a sub SIO, a small ITE chip right here, often found on Gigabyte boards. Let's see on its supply voltage, also on a capacitor. Yeah, high resistance on one side and low resistance on the other, which looks good. Let's see on another capacitor, also high resistance on one side and low resistance on the other. So that looks fine. Let's check for the audio IC. High resistance on one side. Let's see. I don't get a good ground right now. Let's try this again. But yeah, that also seems fine. There's also the LAN IC, so for the Ethernet. And low resistance on one side and high resistance on the other side. Okay, this is what I mostly would look at for standby. There's also VDDP that we could look at, and 1.05 volts for the PCH could be shorted. So let's look for the PCH. This is probably these MOSFETs right here. But 25 ohms looks fine for B450. And yeah, there might be the VPP somewhere like here. This is the ground side probably. Let's check the other side. And the other side has high resistance. Okay, so right now I really don't know what could be wrong here. So we will go over to voltage injection. And we will be using our thermal camera to have a look around. Because this was the most obvious things now that I've checked for standby voltages that could be shorted on here. Visually, there's nothing really wrong with this board. Nothing obvious, at least, like only the PCH area was kind of weird. But I would have expected it would be the SIO. I've just spotted that the SIO has its own little regulator right there. Let's check that once more, just to be sure. Yeah, and that has high resistance. Yep, high resistance, just the ground input is low resistance. Okay, so it should be the 5 VSB that has the problem. So what we're going to be doing, we will probably start with 1 volt into the 5 VSB line and via the power supply and check with the thermal camera what is shorted on our board. So thermal camera is ready right now. And let's now inject 5 volts. Okay, there's almost no current draw with 2 volts currently. So let's go up to 5 volts. And with 5 volts we have high draw, and there is something right there. This I see right here. And there was something down here heating up. This might be the secondary side, but that thing definitely heated up. Let's see, is there something else on this board heating up? No, only that. Okay, so we found our culprit already. The right IC right there. Let's go under the microscope and see what that IC is right there, just for you to show how quickly this heats up. There's also a resistor in front of it. So let's go and see under the microscope what is shorted. So if we have a look now, this IC on the right, this one right there got hot. EM5103BKK4347. No idea what this one does. And also what I think I saw was that capacitor right there also got hot. But I'm not sure what this component is for, to be honest. Like, there's some voltage next to it. But this looks like an operational amplifier, to be honest. This operational amplifier might be used for driving the gates of these MOSFETs. This is what I would expect is happening right here. Let's check. But there's a big output right there, that one. Let's check that with the multimeter. So let's see in resistance mode on this big output right here. Seems to be, yeah, I don't get, is this low resistance? Let's see. Yeah, there. On this side, it's low resistance. And on this side is low resistance. Oh. Yeah. If I can get good contact, this is also low resistance. So this side is definitely shorted. Because this is our ground side. So let's check for this one in comparison, for example. Yeah, this one has 60 ohms in comparison, and this one has 0. So the question now is this a load side? So that our load going out of here is shorted, and this is just supplying a lot of, needs to supply a lot of current, or is this controller itself shorted? This is the big question now. And in order to try that, we could either inject voltage right here at the output and see if the controller itself gets hot, or if something on the output gets hot. But I would be interested in what this is actually for. So first going into the board view and trying to figure out what this actually does. So let's go into board view and let me figure out what this one is for. So now in our board view, and it's this IC right here, AQ2. It is an RT9018B. 3 volt dual as an input. And what is shorted is this AVDD 1.8. So this is probably the 1.8 volt regulator on here that is shorted. Yep, so that is what I expect. So this seems like this is a linear regulator still, just with enable signal and probably power good and feedback, because there's no big inductor at the end. So this is not a big buck converter, but probably a linear one. 3 amp linear regulator, probably. Interesting. Right here it says 3 amps. Okay, so our output is shorted. We will now check on this output. We will need to unplug the CPU and see if our resistance goes high then, because then we will have a problem with the socket. In very rare cases, it's the socket or like a capacitor on this line, but I would expect that it's the IC itself. So let's inject 1 volt again at this point right here on the capacitor, and then see what gets hot, if it's again the IC or if it's something on the load side. So let's check the resistance without the processor in it. Not that we get a short from the socket side of things. So let's go on that capacitor, and we still have a short. Okay, so it's not the processor, not this load side at least. It might still be a capacitor, but let's see now. I have the thermal camera ready, as you can see. There's 1 volt currently attached to these tweezers. Let's get the macro view. So let's see. Is it really the capacitor? Because this is getting really hot. Is it really a shorted capacitor? That is so rare to happen. Let me get a different point of injecting voltage to see it better. Found another spot to inject voltage. And it is the capacitor. Can this really be? Yup, it's a shorted capacitor, 120 degrees. I cannot believe this. Are we really this lucky to get a shorted capacitor on this? Cannot believe it. Wow, that would be great. That would be a nice easy one, because in the last few videos I've only taken L's. Like, I've tried multiple repairs and I've just been really not getting some boards repaired. Like, I've recorded like 2 or 3 hours trying to fix this MSI MPG X570 board that I couldn't get further with, where I got stuck. And then, if you've seen the last video, there's also still the B450 ASRock board that doesn't react to the power button, where I didn't get any further. So yeah, I've been on quite a dry streak lately, and I really hope that, like, just a shorted capacitor would be great for once, to have to just fix a board, get it up and running, and just have that good feeling of having fixed an actual board again. So this is our capacitor in question. Let's get rid of it. Like, some would say that stupid damn capacitor, but for me, I'm happy that I got an easy one on this one. I hope this is all that is wrong. Hopefully I won't eat my words and there's actually something more wrong with this. So let's see. Let's get some. Let it solder on both its sides. And let's see. Just a big blob of solder, trying to get rid of it and making quite a mess. Let's see. We might want to use hot air to get it off. There it is. Just with a soldering iron we were able to get it off. And this capacitor is just a filter capacitor. So it isn't strictly necessary. So now the capacitor is removed. Let's check now if we still have a short circuit. So let's get our multimeter. Get a good ground on this board. And let's check the output now. And now the output has higher resistance. If we now plug a CPU into here, I think we would get lower resistance. Now CPU's in here. Yeah, it's even higher resistance. Let's see. Let's get like 20k ohms range. And there it is. We have like 450 ohm resistance. That is very nice to see. So let's clean this area up. So now the area is also cleaned up. And let's see for the passive power consumption now, and if we have the voltage there that we need, and maybe the board even starts up. So now let's see for the passive power consumption. So we plug all of this in, and now power delivery, and we have 180 milliamps. Still a little bit higher than I would have liked, but 180 milliamps is still fine. And what I want now to see is I want to check with voltage mode. I want to check that 1.8 volts, where the shorted capacitor was on, if that is running now. So getting a good ground in voltage mode. And now checking that pad where that capacitor set. And there we are, 1.8 volts. Very nice. So that is running now. Let's get a power button in here and a speaker. Let's get an indicator for some postcodes also. Let's see if the TPM header actually works with the postcard that I have. And also we'll be putting DDR into here, the DDR postcard. So we might be able to see some postcodes. And let's also get some normal DDR4 RAM into here. So that if it wants to start up, it also has RAM. So that is on. Let's get a small heatsink for the beginning. And the fan also plugged in so we can see if it actually reacts. Okay, so let's see. Let's hit it. No postcodes on the TPM, but 2.4 amps. We have LEDs right here. We currently on DRAM. We're probably RAM training, CPU and RAM cycling again. Let's see. So far still on DRAM stuck. We might need to reseat the RAM. And we might need to check the BIOS if someone has messed with that. But the BIOS looks fine. This does not have a flashback function. Okay. Gigabyte boards, very sadly, are notorious for their very bad dual BIOS design, which really doesn't work well. Let's turn it off once more. Let's reseat the RAM and put it into a different slot. And reset it a couple of times. So now the RAM is reseated a couple of times in a different slot. And let's now try again. Power supply turned on. Bottom right, CPU, DRAM. Let's see, we got LEDs. That is very good. And now we got VGA. I do not have my post monitor connected to here. Let's see. And it's probably auto restarting. Let's see. Let's get a post screen. Let's get a keyboard onto here. So far, 2.5 amps power consumption, 2.8. And jumping, that looks very good. Haven't heard a post beep yet. Ah, there it is. I was just looking at my keyboard. But we have picture. That is very good to see. So let me build this board up then. So we are in BIOS currently. And what I want to do to properly check this board is I want to populate all of the RAM slots to have that check that properly. I will get a actual CPU cooler onto here. So I can run at least some stress tests, and I want to put a GPU into here. So let's try that. So the board is fully built up. We have a CPU cooler, we have 4 DIMMs of RAM, 4 RAM sticks. We have a GPU on here. We have an SSD in the NVMe slot. There's a 3100 in there. It might not support the 3100 from the BIOS, but we will just see if that works or not. So put on the power consumption and turning the board on. Going on to RAM. I might need to reseat some of that RAM. No. A good indication is if the LEDs lights come on, because these LEDs are triggered by the MCU or the secondary I/O ITE chip that is on there, and that really only works if the reset signal is off and the power OK signal is there, and only then the LEDs turn on. So that is a good indication when a board is turning on or not. We now have VGA. We should get a post screen. This is still the stuck post screen from before. We have 3 amps of power consumption, 3.5 amps currently, 3.4, going to 5 amps, and there's a post beep. That is very good. And there it is. It now is trying to go into Windows. You can see it is loading. We have about 5 amps of power consumption, spiking. That is very good, because we also have a GPU in here, all of the lights, and on startup, because it's already working, trying to get into Windows. And I will be running a stress test on here, and I will be seeing how this board will react to it, but I don't think that there's going to be any problem, because all we had was a shorted capacitor with it, which is like, I have, in all of the time when I have been fixing motherboards, this is the second motherboard only that has a shorted capacitor. Like, it is extraordinarily rare to have a shorted capacitor on a mainboard. Like, if you've seen the laptop repair videos a lot, there's very often shorted capacitors, because they have a different amount of stress. They get rotated a lot. They have a lot of physical stress, because the laptop is always moving and getting hit. And they also have a bigger heat restriction, because they're in an enclosed area where they get heated up way more, and they have more heat cycles. On a PC board, all of these capacitors are basically free. Like, they get no movement at all, because in a PC case, it's just standing. It might get a kick here and there, but nothing else. And it most of the time has very free airflow, all of the capacitors that are on here, on a mainboard. So very, very rarely does a capacitor fail. I had it once before on the 5VSB line, close to the audio chip, that there was a shorted capacitor. And I don't know how many boards I've fixed, or I've seen, like maybe 150 boards I have fixed now. And in all of those times, only 2 of them had shorted capacitors, which is like, that just shows you how rare it is to get this lucky with a board where just the output capacitor is just so shorted, just taking it off without even replacing it, just throwing it, just starting the board then. But I'm really happy with it. As you can see, it works. I will be connecting Ethernet to here. We'll be testing some of the USBs, and we'll be doing some stress tests. But this thing won't fail with those. This thing is definitely working. And in a working state, we pull about 5 amps with 12 volts of power consumption, which is great. I might want to see if I can maybe clean up this heatsink a little bit more. Sadly, this thing is missing whatever was here before, but what can you do? Well, I'm still happy with this board. I hope you enjoyed the video. I hope you learned something. Yet again, shows how important it is to see the passive power consumption of a board as soon as you plug it in, because you could regulator, 1.8 volt linear regulator, pulled a lot of amps. It put one whole amp just by itself, and that is that's a lot. That's a very big power consumption. On 12 or on 5 volts, pulling 1 amp for that regulator is really a lot. And that capacitor, if you would have left, that capacitor might have at some point just cracked, because it got really hot, or the regulator itself could have died. But in this case, we were very easy able to spot it. And just in the first second of power consumption, we already knew that something on the standby side was faulty. And yeah, it made it really easy for us to recognize what was there in the thermal camera. I've told it many times, the infrared P2 Pro, that thermal camera is just a blessing. It just works so great. I'm really happy with it, and was really easy to spot that capacitor. I wouldn't have thought that it's the capacitor. I thought it would be the regulator, but we got lucky this time. Thank you very much for watching. This was Mainboard Medic. Thank you very much, and goodbye.